Hey guys, so I hope you remember that in the last lecture we talked about the very two important gas laws, that's the Boyle's law and also the Charles law. Now, if you don't remember, I would put up the link to so that you can check, but basically that meant P1 V1 equals P2 V2. When you change the volume, the pressure changes according to this equation, keeping in mind the temperature is constant. And Charles' law says V1 upon T1 equals V2 upon T2. Now, at the end of that video, we talked about a question, right? Now, if you missed solving that question, I'm going to take a pause of a few seconds and you can pause the video right now and go and try to solve it. And then we'll carry ahead and understand what is the combined gas law equation. Okay, so what is the combined gas law equation? So we already have the two gas laws, that is P1 V1 P2 V2, V1 by T1 upon is equal to V2 by T2. Now combined gas law basically combines the Boyle's law and the Charles law into one single equation, which is P1 V1 upon T1 is equal to P2 V2 upon T2, right? Now remember, the Boyle's law had temperature as a constant. The Charles law has pressure as the constant. This law has mass as constant. Also, mass was constant in those two laws as well. So here, the only constant thing is the mass of the gas doesn't change. You don't add or don't take away anything, right? So a neon sample placed at 27 degrees, remember, now you have to convert everything into Kelvin. So that is 27 plus 273, which I think is 300 Kelvin. That is our T1. 985 torr, that's our P1. 105 liters, that's our V1. Pretty simple, right? Can you find the volume it would occupy at standard temperature and pressure? Now, this is where things get really interesting. What's standard temperature and pressure? Now, this is just an international agreement which says that by international treaties, or not treaty, mutual understanding, 0 degree Celsius or 273.15 Kelvin is the standard temperature, and the standard atmospheric pressure is 1 atmosphere, 1 atm, that means equals 1 atmospheric pressure, or in torr, that is 760 torr, or this is also equal to 760 mm of Hg. Now, let's try to solve this one. And this is kind of very easy. So now you know your T2 is 273, your P2 is 760. So let's write on the equation. So 985 multiply 105 divide 300 equals P2, 760 V2, we don't know. That is a question, V2. And the T2 is 273. You can simply round it off to 273.15 is just like too accurate. Now, so let's find out for V2. So we have 985 into 105 into 273 upon 300 into 760. Funny question, right? That's our V2. Now, I am going to leave the maths to you, but because I have already done it. But if you do that, that comes out to be 124 liters. Now, remember a neat trick. Just to keep your work clean, you can avoid writing the units here. You can, not that you should. So you can say V2 is 985 torr bracket 105 liters bracket 273 Kelvin bracket upon 300 Kelvin bracket 760 torr bracket. And the answer comes out to be the same. So some professors sort of prefer this, while others are happy as long as you can keep things clean and neat. All right, so it's definitely up to you. Let's solve one more question at least to practice the combined gas equation. So I'm going to take a pause here. The question is for you to pick the variables and then put in, and then let's try to solve it right now. I'm going to take a pause. Okay, so I hope you did solve and you did not just wait for the 5-second pause that I gave, right? So 12 liters V1, 240 degrees. So 240 plus 273, if you do the maths, 3, 7 for 11, that comes to be 513 Kelvin, that is your T1, was placed under pressure of 80 kilopascals. So that is your P1. What would be the temperature if the V2 is 15 liters and the P2 is 107, right? So let's use the combined gas equation. P1 V1 upon T1 equals P2 V2 upon T2, right? So that comes out to be 12 multiply 80 upon 513 equals 107. Volume is 15 and T2 is just like that. So if you rearrange for T2, that should be 107 times 15 times 513 upon 12 upon 80, right? At the same time, you can put in the units there and that would work just fine. So that comes out to be 858 Kelvin. If you just get out the degrees, so in degrees that would be minus 273. Remember, 858 minus 273, that comes out to be 585 degrees C, right? So that's your answer. So you see, gas laws until now, it's sort of pretty smooth, right? It's pretty amazing, easy, right? So I'm gonna put the link for the next video where we take it to the next level. We go and dig in the Avogadro's law, the last law, and finally go to the ideal gas equation and try to understand what's the ideal and real gas scenario.
We hope you like this video. Press subscribe, thumbs up, and stay geekly.